Okay, so today, as I said, we're gonna do two problems. Example number one, pretty straightforward. Example number two, we will see. Okay, in my opinion, it's more sophisticated. Okay, we will see. You will decide by your own. And topic of today's things is elementary motion. Okay, elementary motion. Yeah, we have to start somehow. And as I said earlier, example number three will be posted on Canvas. Okay, with a couple of hours. Okay, example number one. Let's do it. Oh, one more thing I forgot. Do you know that those problem statements are already on Canvas? So yeah. So I have a. Do you mind doing me a favor? Can you please read them and familiarize yourself with the problem statements before the discussions? Okay, so that we don't spend time on reading, basically. Yes. But since this is our first discussion, please familiarize yourself with the problem statement before we start our solution. We will start in like 1 minute or something, or less. All right, so what do we have in here? We basically have our acceleration function that is basically given to us explicitly, yes? We have our acceleration as a function of velocity, right? Yeah, and we have our initial conditions. Yeah, and basically what they ask us to find, is this expression, not this one, but they just would like us to reach from here. They just would like us to maybe you know what. This is our goal. T as a function of position, right? Determine the time required to reach this thing. Yeah. So actually not exactly this, but also we at the very end, after obtaining this function, we should put here not S but SD. Yeah. So this is our goal. So let's do it. Solution. So we basically know that our acceleration is given by this function. And I think that the first step should be to integrate. Yeah. So let's reach the velocity level. Yeah. So let's go from acceleration to the velocity level. Okay. So I believe that we are just going to use this definition, yes, of acceleration. A is equal to dv dt. Okay. So I can plug it here, dv dt, and this is equal to minus k v squared. Okay. Do you remember what was the next step in these problems? Basically, everything with v on one side, everything with t on the other side. Yeah. So we will end up with dv v squared, and this is equal to minus k dt. Okay, let's integrate. And I believe that our integration bounds are given here, right? So we will start with v0 at time 0, right? Because v0 is here and time 0 is here in the argument. And we will end up with certain velocity v, we don't know, at some time t. Yes, they correspond to one another. Okay, if I remember from, I think I know how to do this integral. So that would be minus 1 over v0 v, and this is equal to minus k from 0 to t. Oh, minus kt, of course. Okay, let's plug our integration bounds, and we will end up with minus 1 over v plus 1 over v0, and this is equal to minus kt. Okay, let's find v. So I think we can do it maybe here. So I would like to do something like that. V, and this is equal to 1 over v0 plus kt. Very quickly, I know that all of you know how to do that. kt v0 plus 1 divided by v0. Okay, so in order to, this is just a reciprocal of one of v, yeah? So in order to find v, I just have to flip it, yeah? So our v is equal to v0 k v0 t plus 1. Okay, this is expression for velocity. Even velocity is expressed as a function of time. Yeah, but this is not what they ask us for, yeah? They want us to go even further, yes? To the position level, yeah? Or displacement level, yes? Yeah, but before we do it, is it okay so far, guys? Do you like it so far? Yeah, any questions? Do you hear me well in the last row? And how about font size? Font size is okay? Do you see it, everybody? Great. Okay, so we are done with, like, I don't know, let's say 40% of our problem. Now let's find position, yeah? And the steps are exactly the same as before, yes? I mean, not exactly the same, analogical, yes? They are analogous. So if I remember correctly, our velocity by definition is ds dt. I'm just going to plug this expression here. Let's say here. ds dt, and this is equal to v0 k v0 t plus 1. Okay, what's the next step? Of course, everything with s on one side, everything with t on the other side. ds is equal to v0 k v0 t plus 1 integral. And maybe some of you can help me with integration bounds. What do you think, guys? What integration bounds shall I plug in here? Anybody? Or nobody? You. One more time, please. To SD. Okay, you could probably do it to SD. Can you do it? You can do it, yes. I'm going to do it to S, okay? But you can equally do it to SD. And for the time? Perfecto. Okay, integrate. And we'll end up with S, and if I remember correctly from school, this will be V0 divided by KV0 log natural KV0 t plus 1 from 0 to t. And that will be basically this. Yeah, and I can simplify it even, yeah? I can simplify this guy with this guy, yeah? This is 0. So we can even simplify it further. Okay, so we will have very quickly. Sorry for, I don't know why I wrote it like 3 times. That was not smart of me, sorry. Okay, so we have expression for S right now, yeah? So this is basically position expressed as a function of time, right? Is this what they ask us for? Not yet, yeah, there's one extra step, yeah? Because they ask us to do something opposite, yes? To find an opposite function, yeah? So they would like us to go for time expressed as a function of position. Okay, so let's do it quickly. So we will basically have Ks, this is equal to log natural kv0 t plus 1. And that would be basically, I solved it yesterday. So that would be basically EKS KV0 t plus 1, and t is equal to 1 over KV0 ESK minus 1. Great. So this is our t expressed as a function of position. And again, is this the end of the problem? I mean, gentleman in the red shirt already said it, yes? It's not, because we are not fishing for the entire function, yes? We just would like to find, so this is basically like a function, yes? Like a curve. But what we want just one value, yes? So we just must plug in here SD, yeah? So I can copy this, basically, or so basically we want to write that, yeah? T is equal to 1 over KV0 E as dk minus 1, yep. And it won't be t, it will be like, I don't know, t star, okay? T naught or something, yeah, t star. So this is our answer. All right, that's the end. So far, so good? Okay, but that problem was easy, in my opinion at least, because note that, actually, you know what, we will see why it was easy, okay? Once we see the second problem, we will see it. Before we move to the second problem, are there any questions? No. Okay, so example number 2, yes? This one. Please familiarize yourself with the problem statement before we start our solution. And I forgot about one thing. Name, last name. Just, I want attendance. Professor Sony asked me for attendance. Guys, please familiarize yourself with the problem statement. All right, so let me explain you this with simple words, okay? So what do we have in here? From the mathematical standpoint, okay, or from the modeling standpoint, we have a point that goes along this trajectory, okay? Our point makes those circles all the time, okay? And at some point, our point is at this position. Okay, so x will be minus 20. Here is minus 20. And and minus 20 is also here, yes? But they told us that y component should be positive. Yes? So basically, they told us that our point that was following this trajectory at some point is here. And they told us to give them everything about that point. By everything, I mean position, velocity, and acceleration. Okay, so our goal is to basically find these three vectors right now. R, V, and A. Okay, are there any questions to the problem statement? Let's do it then, yes? Let's do it. And we also know that, for example, velocity is constant, yes? And we know the geometry. We know the geometry also. Okay, so let's start with position maybe, okay? So R is equal to x, y, z. And they already told us that x is minus 20, z is 0, and I believe that y we can find from this expression, yeah? So y is equal to r squared minus x squared, square root, yeah? So plug in values, 25 squared minus 20, square root. If I remember correctly from school, this is 15. Okay, 15 feet. Okay, so I believe that 33% of the problem is done. Yeah, we found position. And if you don't mind, guys, I just would like to write this quickly, maybe. Maybe not. Okay, it's fine. Questions? By the way, this is that green vector here. Yeah, this vector is exactly this vector here, that green vector. Velocity, let's do it. But I will need your help to do it, okay? So if I remember correctly, velocity is basically first time derivative of position, yeah? So I can basically write d dt of x, and y expression for y is here. So I can write basically r squared minus x squared, 0. And I believe I can enter with the derivative inside the vector. d dt x, d dt r squared minus x squared, and 0. Okay, guys, so basically, in order to find the velocity vector, we must find these two things. This one and this one, okay? Let's start from the beginning. Let's start with the first one. Let's start with this. Can anybody help me? And can anybody tell me what is this? dx dt. dx over dt. Anybody? Yeah, it's not, but thank you. Yeah, I will explain what is 120 in a second. Okay. Yeah. Thank you. Yeah. And name? What's your name? Lars. Yeah. Okay. Yeah. Anybody wanna tell me what is dx over dt? Velocity. Exactly. Yes. Okay, so I don't know what happened with you guys, but you're again right. Yeah, so this is the first year. So I taught like previous discussion, yeah, like 1 hour ago. So this is correct answer, yes. Yeah. And usually people in the past, people were saying it's 1 or 0, or I don't know. But this is correct answer, yes. This is exactly the velocity component in the x direction. And the correct answer is, we don't know what that is. This is actually the correct answer. Okay, so what happened to the mathematics department then? Something happened. Okay, so basically this is x dot. Okay, x dot, and we don't know that value yet. We don't know. Nice. I'm surprised. We don't know this value. However, I think that there might be like still some people who thought that this is 1. Okay, so do you mind if I just explain why this is not 1? Yeah, I can do it. Yeah. So can you guys tell me what is this? dt over dt. This is 1. Yeah. What is this? dx over dx. What is this derivative? Always. That derivative is always 1. And this guy, dx dt, I don't know. Yeah, because why we don't know? Because we do not know the expression for x. We do not know x as a function of time. Do you remember previous problem? Example number 1, we knew exactly the explicit expression for everything. Yes. In here we don't know. We don't know it. Yeah. That's why instead of dx over dt, I'm gonna save some ink. Okay. So instead of that, I'm going to be writing x dot. Okay. They are equivalent. Okay. And this is like a question mark. Nice. Thank you, guys. Very nice. Okay, so we are done with our first expression. Yeah, we don't know what it is, and we cannot do anything with it. So let's move forward. Maybe later we will figure out. And Lars is going to help us. By the way, so now second expression, d dt, r squared minus x squared. Okay, so now I would like to differentiate that, but maybe I can start, and you can guys help me later, okay? So I believe that the first step of this differentiation is 1 over 2 square root r squared minus x squared plus, times what? Anybody? Two r minus 2x. Unfortunately not. Minus 2x, exactly. That's true. That's true, yes. And that's it? Or is there something more here? What do you think? Yes, exactly. dx dt, yeah? Or I told you like 1 minute ago, I'm gonna save my ink, okay? So I'm gonna write in here x dot. Okay, let's simplify that. So this is basically minus x dot, r squared minus x squared, bang. Okay, so look guys, what just happened? So we basically have our velocity vector that looks like that. X dot minus x dot, r squared minus x squared, 0. Yeah, this is our velocity vector. Yeah, so look, we don't know only one thing. We do not know what this thing is. X dot. Do you see? This is the only unknown. This is the only unknown in our vector. Because we know what is x, we know what is r. Yeah. Once we have x dot, we know velocity. Yes. We have the vector. Okay. Any idea? Maybe we can use something what Lars said earlier. Any idea how I can find x dot? Perfect. And v is the length of the vector. Yeah? It's a magnitude. Exactly. Yeah. So basically, what Lars proposed, Lars said that we should use another known they gave us. Yeah. They told us first of all, that velocity is constant. So basically, at every point, everywhere on the trajectory, the length of this vector, this red vector, is constant. Yes, and it is equal to 120. I'm gonna do exactly what you said. Yeah. Okay. So, and let's put it in the mathematical formalism. Yes. So basically, you said that I should take this magnitude, and I should say that it's equal to 120. So this is magnitude. No. I should take that, yeah? And you said that this is equal to 120. Perfect. Thank you. So yeah, again, we have one equation and one unknown, yes? Yeah, I know, guys, that you probably solved like 700 of such equations, yes? So let's do it quickly. Do I want to show you steps, or maybe a little bit I can show you? Why not? So basically, we will have here v that is equal to x dot absolute value 1 plus x squared r squared minus x squared. yeah? And I believe that I want to find x dot, yeah? So basically we will have x dot absolute value that is equal to v divided by that square root. Okay, and if you grab your calculators, you will see that this, you can plug in values, just plug in values, grab your calculators, and you will end up with x dot equal to 72 feet per second. Yeah, and this is absolute value. So I believe that our x dot can be actually equal to 72, or x dot can be equal to minus 72. Yes, I think that this is what they told me at school. Okay, so we ended up with two values of x dot, and I hope that everybody followed what I did. If not, there will be time for questions. Don't worry. So we ended up with two values of x dot. One is true, the other one is not true. Which one is true, in your opinion, guys? The negative. And why?
Because, well, the vector, the velocity vector is always tangent to the movement, and you can see that it's going down. So therefore, the x and the y.
I see. Yeah. It points to the left and downwards. Yeah. At that point, of course. Yes. At this point. That's why. Exactly. Yeah. You see that velocity vector points towards the negative values at x. Yes. So it will be minus 72, not positive 72. Yes. It will be perfect. So this is not physical. Not physical. Okay. Yeah, but this is physical. And as I promised, once we found x dot, yeah, we know the entire velocity vector. Okay. So now you guys can write that. Just plug in values here. Wait a second. Plug that value here, please. And you will basically end up with velocity equal to minus 72, 96, and 0 feet per second. Great. 66% of the problem done. Yes? Let me see. It's plus. It will be plus. After plugging in values, it will be positive. Or maybe you're right. Yes. Minus. Okay. Because of that picture. Because of that picture, yes. Sorry, I just looked at my solution yesterday. I forgot about that minus. Yeah. Interesting. Okay. Oh. Yeah. Okay, guys. Yeah.
Sorry, just a quick question. When you got the 72, when you said plug in your values, were you using x is equal to negative 20?
Yes. Yes. And there was one more question.
Did you figure that it couldn't be positive 72? It could only be negative 72?
Sure. It can only be at that point only. At this point. Because look, so if I draw components of our vector, look, if I have, so this is my x dot, and this is my y dot, basically. Do you see? Yeah. So x dot points towards negative values. That's why we have to eliminate positive one, and the negative.
Only applies at that point.
Yes. Yeah, we focus only on that point. Good, very nice question. Yeah. Try to imagine what we are doing like that exactly. Yes.
When you take the derivative of square root of r squared minus x squared, you put dx over dt once you solve it. It probably has to do with chain rule. I just don't know exactly what you put the dx dt.
It's a chain rule. That's why we have office hours also. Okay. Today I have work to do. If you have questions, please visit us during office hours. Okay. Yeah, I would love to answer your question. However, I know that exactly what I want to cover today, is 50 minutes, okay? It's yeah, I came prepared, sorry. Yeah. But I'm also willing to stay after the discussion and talk like for 5 minutes, okay? Questions? So far so good, guys? Do you follow what I'm trying to get at, more or less? Okay, you have questions after the discussion, office hours, okay? Or piazza is even better. Or no, I know, they are equivalent. Okay. Okay, acceleration. So we have position, we have velocity, now acceleration. Let's do it? Let's do it, okay. How much time do we have? 12 minutes, okay. Oh, quickly. Okay, so now acceleration. Okay, so basically we have to find these two values, x double dot this time and y double dot. So once we have x double dot and y double dot, we can call it a day, yes, and we can basically go home or wherever we want to go. And that was a tricky problem, you know. I solved it yesterday, basically, and I figured out that I must come up with the fastest way to solve that problem if I would like to show it to you today, okay? So in order to solve that problem, I'm going to show you two tricks, okay? That will solve them very fast, okay? So trick number one. Trick number one. Which equation I would like to take? I would like to take this equation, guys. I would like to take exactly this equation. This one. Okay. Yeah. I would like to take that equation, and I would like to simplify it. However, let's get rid of that absolute value. Okay. Let's get rid of that absolute value and let's put minus in here. Yeah. Okay, because our x dot was negative value, yes? Okay, and I would like to simplify this denominator, okay? So what I would like to do it like that. 1 plus x squared, r squared minus x squared. And I would like to express this one in an intelligent way, okay? I believe that this one can be expressed like that. R squared minus x squared divided by r squared minus x squared. Yeah, I can always do it. This is one, basically, yes? Okay, so let's do it. R squared minus x squared plus x squared divided by r squared minus x squared. I think I can get rid of these guys. And we will end up with something like that. R plus r squared minus x squared square root. And by the way, if you look at the problem statement, this is y. This square root is y. Do you see it? Yeah. So I told you we're gonna simplify it. Okay, let's plug it back in here. So this will be basically minus v divided by r times y. And by the way, this is constant. V is constant, r is constant. Yeah. So they're this fraction is also constant. This is constant. So in order to obtain x dot in the fastest way, in my opinion, we just have to differentiate this equation twice. Yeah, do you see? So basically we ended up with x dot is equal to minus v r y. So basically our x double dot will be minus v r y dot. Yeah. And we basically know everything on the left-hand side, on the right-hand side, sorry. So our x double dot will be minus 120 divided by 25. And if I remember correctly, y was minus 96. Yeah. Grab your calculators and obtain that this is 460.8 feet per second square. I don't have space. Okay. Any questions to what happened? Yeah, it was a trick. Yeah. There are other ways to obtain it, but they are longer. Okay. Okay. So now we need to find. So basically, we have now this 460.8. This is 0. And we just need our middle component, yes? Let's do it. Let's find y double dot. How can I do it? Which one? There is trick number 2. Trick number 2, okay? I would like to take this expression right now. Oh, this one. Sorry. So I hope that you guys remember that we can always write our velocity in such form. X dot, y dot, and z dot, okay? So I just would like to take this expression right now. This one. Okay? So basically, y dot is equal to minus x dot divided by that square root. And by the way, that square root is again y. Yes, we can replace this square root with y. This is y. So we can end up basically with such expression. So basically it's gonna be minus x, sorry. So it will be y dot y minus x dot x. It's like, there's like some bit of symmetry in this expression, okay? So let me copy it there. Let me copy this expression here. And in order to obtain y double dot, I just would like to differentiate twice. Okay? So I just would like maybe some of you to help me for the, I think it's the final time today. Yeah, if you don't mind, guys. So can anybody do the time differentiation of this thing, of the thing on the left side, please? No, but you can think again. You can think again. It's fine. Anybody?
Y dot squared plus y double dot y.
Perfecto. Yes. Yeah. Yeah. It's not what you said, right? It's not what you really.
I just said y double dot times y double dot, but it's
Okay. for the yeah. Okay. So sorry. Apparently I didn't hear it well. I'm sorry. Yeah. So and I'm not going to ask you to do the right hand side because it's basically symmetric. Yeah. It's basically the same. Yeah. Yeah. Really, is what you said? I heard something. Yes, that's what you said. Yes, yeah, yeah. Anyway, don't worry. Okay, and again, this is the one expression and one unknown. Yes, because the only thing we do not know is this. This is the only thing we don't know. Yeah. Everything else we know. So you guys know already how to find y double dot, yes? One equation, one unknown. Okay, so I think I even remember those numbers. So let me plug them in. So that was like minus 96 squared, yeah? Plus y double dot. That was 15. And this is equal to minus 72 plus 460.8 times, I believe, minus 20. Okay, guys, so you can see that we have like all numbers and one letter only, yes? So let's not spend time on that. Okay, and if you use your calculators, you will get this number, 3456, with a dot here, with minus, and this is feet per second square. Okay, we have like 2 more minutes, so let me just write down this. So we actually found acceleration, okay? And please let me know if you have questions, okay? 460.8 minus 3456 feet per second square. Yeah. But before your questions, I would like to say take-home message, okay? Because what we did today, we solved 2 examples, yes? One was easy, more or less, yeah? That one was more complicated, yeah? Why? What's the difference between them? Take-home message, in the first one, things were given explicitly to us, yeah? In here, they were not. And if they are not, you might invest more time. Yeah, the solution is longer, basically, yeah? This is take-home message. Thank you for today, unless there are questions. Or I can stay 5 minutes after, yeah. Okay, guys, have a nice afternoon. Bye.